So let's move on to the next one. That is the last sum and the last part of your exercise, as well as the chapter also. As I told that as we divided this chapter into two type. Your first exercise, it is based on the formulate, and the second exercise, it is based on the graphical method. As I hope you all understood the graphical method and even the how to frame, how to formulate the LPP. Till now we took four sum. First three sum, it was based on one single type, and the second sum just now only we saw in the previous video. The sum was a little different. What was the different? What was the change? As we got there linear equation in two variable as well as linear equation in one variable. Yes or no? And this is a little complete different sum, and it is very important. As I will say, it is one of the very important sum from the exercise, as well as importance for as a board point of view also. So here clearly you can see that the sum actually is based on what a speed, distance and time. Here you can see the speed, kilometer per hour. Then here we have the cost also, rupees also, and then maximum distance. As clearly we can see that the sum actually is based on speed, distance and time. Now first we'll see the concept. As whenever you come across this types of sum, as the sum it is based on speed, distance and time. So here I can say this is a small int, we can say. Okay, what is the int here? As it says that formulate the above problem as LPP wishes to travel maximum distance. Here it is clearly mentioned that maximum distance within an hour. So the int is what? The int is very simple. To which part we have to consider x and y, and to which section we have to consider z. So here a clear int I'm presenting in front of you all. Whenever you come across this type of sum, as a sum it is based on speed, distance and time. So be careful while preparing the value of z. As for this type of sum, we'll consider z as the distance only. We'll see now how much distance is covered in a certain time period or in a certain speed. So remember one thing, that the z will be what? The distance part. And whatever the linear inequation, from where you will get the linear inequation, one from the cost or price. As we know that the unit for cost and the price, it is rupees. But in the previous 3-4 sums, what we saw that from the rupees section we got the idea about to which section we have to consider as x and y, and how to frame the value of z. From the rupees we got the idea. So here the rupees section will be what? From there you will get the linear inequation, not the value of z. So remember this, the value of z will be what? The distance part. So that you have to check now how much distance it's covered in a certain time period or in a certain speed. Okay, so now remember, whenever you come across this type of sum and you see the rupees, as clearly we can see that here we have three rupees and rupees. So remember, three section 3 rupees. When we have 2 rupees, 1 rupees for suppose cement, 1 rupees for brick, so and so, yes or no? So that time you will consider that sentence as a z. Here we have 3 rupees, one the total rupees, here 1 rupees for cost, and so it is there. Just I just want to say in a simple language that whenever you come across this type of sum, whenever you see the rupees section, from the rupees section you will get the idea about the inequation, how to frame the inequation, not about the z value you will get from the distance only, okay. So now let's focus on the concept here. Okay, how you will get the idea about the z, how we will frame the inequation. And there is one more thing, you will apply the formula. As we know that the formula is speed equal to distance upon time, but here we'll use time equal to distance upon speed to get our linear in equation. With the help of a diagram, I will try to explain this sum. Okay, now focus here. If John drives a car at a speed of 60 km per hour, he has to spend rupees 5 per kilometer on petrol. If he drives at a faster speed of 90 km, then the cost of the petrol increase to 8 rupees per kilometer. Now we spend total how many rupees on a petrol? 600. And he wishes to travel a maximum distance within an hour. Now suppose a John is driving a car and he has to cover a certain distance from here to here within an 1 hour. It is clearly said that he wishes to travel a maximum distance from here to here, and we don't know the maximum distance is what, whether it is 30 kilometer, 40 kilometer, 60, 70, how much distance he has to cover within an hour, that exactly we don't know. But one thing we know that it drives a car at a speed of 60 kilometer and he has to spend 5 rupees on per kilometer of petrol. And after that it drives at faster speed of 90 kilometer per hour. It says that suppose is starting his journey from this point and he has to travel till here and he has to cover a certain maximum distance within an hour. Suppose he started his journey from here, he drives a car at a speed of 60 km per hour and he has to spend 5 rupees 5 per kilometer on petrol. So he started his journey from this point, he drives a car, suppose till here at a 60 kilometer per hour. After that from this point he has increased his speed. From year to year it travelled with a speed of 90 km per hour. Okay, again I will explain. Assume that he started his journey from this point and he has to cover a maximum distance within an hour. So from year to year he has to cover a distance in an hour only, within an hour. Okay, that means we can say less than equal to 1. Within an hour he has to cover either the distance less than 1 hour or exactly at 1 hour he can cover the distance. He has to wish to travel the maximum distance within an hour. So whenever the word come within an hour, it means less than equals to. Okay, so now once again, so now it travels a distance from year to year. We'll consider the speed. It travels from year to year at a speed of 60 km per hour and he increases the speed from year to year and he covers a certain distance now at a speed of 90 km per hour. Now we don't know exactly how much distance he had covered at a speed of 60 km per hour. So this distance will consider as x, and we don't know at a speed of 90 km per hour how much distance he had covered. Yes or no? So we'll consider this from year to year distance as x and this distance as y because we don't know. We know only one thing, that it drives a car at a speed of 60 kilometer per hour. Suppose we'll assume that it covers a distance from year to year with a speed of 60 kilometer per hour. Now after that from this point to this point, now he is driving his car at a 90 kilometer per hour and we don't know exactly that how much distance he had covered at 60 kilometer per hour and how much distance he had covered at 90 kilometer per hour. So we'll take that John travel x kilometer at a speed of 60 kilometer per hour, y kilometer distance at 90 kilometer per hour. Got the point? So from here we'll get the idea about z, that z will be equals to what? He has to cover a certain distance from year to year. So the total distance will be what? Total distance. So total distance, total means what? Plus he has to cover two distance now, one at a speed of 60 kilometer per hour and one at 90 kilometer per hour. So he has a distance x and y. When you will add, you will come to know the total distance. As I told in this, for this sum, whenever you will come across the sums based on speed, distance and time, the int is very simple. Okay, to the distance section you will consider that sentence as a z. So, so here in this sum, z you will get from where? From the distance part, not from the speed and time. Remember this. Okay, I hope you all understood the first part, how we got the value of z. Okay, so here this is the hint, distance will be z. And what about the cost? From that cost, from that rupees unit, you will get one linear inequation, and with the help of using the time, distance and speed, you will get second linear inequation. So now let's focus on how you will frame your linear inequation. Okay, so once again I will explain the sum. As he started his journey from year to year, he has to travel maximum distance within an hour, that means less than equal to. So exactly we don't know the distance, maximum distance, how much he has to cover. But he started his journey from year to year, suppose at a speed of 60 kilometer per hour. After that he increases his speed at 90 kilometer per hour. What we saw, he covers a distance from year to year. That exact distance we don't know, so we took x. And from year to year we don't know the exact distance, so we took y. When he was driving a car at a speed of 60 kilometer per hour, he spent rupees 5 on 60 kilometer per hour, and on 90 kilometer per hour he spent rupees 8. And he has to spend total total cost was 600. Yes or no? I hope you all understood the graphical method, that how I had explained the sum with the help of a diagram. Okay, so now let's start how to frame, how to present the sum in the board exam. Okay, so here we'll write what? Let John travels x kilometer at a speed of 60 kilometer per hour and y kilometer at a speed of 90 kilometer per hour. Understood? He had covered x kilometer at a speed of 60 kilometer per hour. At 90 kilometer per hour, he had covered x y kilometer. So total distance. Distance. So that total distance actually it is what? Z part. As I told, the int is what? A distance part we will consider for this sum as z. So z will be what? A distance section. So here he has to cover a total distance from year to year. So total distance from year to year, it will be what? X plus y. Yes or no? Now the next part will write what? Time to travel x kilometer is what? So now we'll apply the formula, this one, time equal to distance upon speed. So can I say that this is what? A distance, this is what? Speed. So you will get one formula, that is time equal to distance upon speed. Yes or no? So time to travel x kilometer is what? X upon 60 kilometer. Yes or no? Time to travel y kilometer is what? This is what? Distance, and this is what? Speed. So you will come to know that it is in the form of time equal to distance upon speed. So time is equal to distance is what? Y. Speed is what? 90. 90, here hour will come as we have to find the time to travel. Yes or no? Time to travel. So here unit will be what? Hours, not kilometer. So time to travel x kilometer is x upon 60 hour. Time to travel y kilometer is y upon 90, because it will come in the form of time equal to distance upon speed. So this is time equal to distance upon speed. Time equal to distance upon speed. Understood? So therefore the total time. So the total time taken will be what? Will add this two part, x upon 60 plus y upon 90 hours. Yes or no? After that it says that he has to wishes to travel a maximum distance within an hour. So within an hour, so we'll write here John wishes to travel maximum distance within an hour. So therefore, using the concept that is time equal to distance upon speed, so x upon 60 plus y upon 90 wishes to travel maximum means less than equal to within an 1 hour. An hour means what? 1 hour. So here we got one linear inequation with respect to time equal to distance upon speed. I hope you all understood how I had framed and the equation, as well as how I had explained this sum with the help of diagram. Okay, refer the sum, see the video 2-3 times, then you will come to know exactly what I had explained and how I had framed the equation, how I got the value of z as well as the first linear inequation. Let's move on to the next linear equation, how you will get. After that, you will write that John has to spend rupees 5 per kilometer at 60 kilometer per hour and rupees 8 per kilometer at 90 kilometer per hour. So the total cost is what? Rupees 5 on 60 kilometer per hour. So we took x kilometer for 60 kilometer and 8 rupees at 90 kilometer. For 90 kilometer we took 9. So therefore the second equation in linear inequation will be what? Rupees 5 for 60, rupees 8 for 90. Okay, as he had spent 600 rupees only, not more than that. 600 only, na? He has to spend on petrol and he wishes to travel maximum rupees, not more than that. Yes or no? So he has to spend only 600 rupees, not more than that. It means what? Not more than that. Just now only I had explained, not more than that. That means he had to spend only 600 rupees, not more than that. Not more than that means what? Less than equal to. He has to spend only 600 or either less than that. Okay, so from here we got the second linear inequation. As I told, the int also, first linear equation will get from where? From the cost 5 rupees, 8 rupees and 600. So 5 rupees is on what? 60 kilometer and per hour, and 8 rupees is on what? 90 kilometer per hour. So 5x plus 8y, he has to spend 600 on the maximum distance. So maximum is what? Less than equal to. So here we got the second linear inequation also. Yes or no? So now the next part you will write what? Since x and y cannot be negative, so we have x greater than 0 and y greater than 0. I hope you all understood till here. Okay, so I had explained this sum with the help of one diagram, so to make the concept clean and clear. Okay, just revise the sum 2 3 times, or just focus on the explanation part, what exactly I wanted to explain. And this sum also, without using the tabular method, I had framed the equation. So your question number 8th and 9th you can frame without using the table, directly by reading the sentence. Just read one sentence, you will come to know that from that particular sentence what you will get. So for this sum also I did the same thing. I read one sentence, so here I got about what exactly I have to write, what I have to mention, and I'd explain this sum with the help of diagram to make the concept more clear and clean. So remember, z from the distance you will get. Just remember this int. Okay, and the story you can write by yourself. Z you will get from the distance. Linear inequation you will get from where? With the help of this formula, time equal to distance upon speed, and with the help of the cost and price. As the cost and price unit is what? It is in rupees. So wherever you see rupees section, from there you will get what? Linear inequation, not the value of z. For the previous three sum we got the value of z from the rupees section. Okay, remember this. For this sum, rupees section will be what? Linear equation in two variable. Okay, so last part will be what? We'll write given problem can be formulated as follows. As we have to find the maximum distance, so maximize z is equal to x plus y, yes or no, subject to x upon 60 plus y upon 90 within an hour, that means less than equals to 1. And the second one is what? 5x plus 8y less than equal to 600, x greater than equal to 0 and y greater than equal to 0. So once again, so from the distance we got the value of z by using the formula of time equal to distance upon speed, and with the help of cost and price we got the two linear inequation, yes or no. Okay, from distance you got the value of z, and using the formula distance equal time equal to distance upon speed and cost and price you got a two linear inequation. Understood? I hope you all understood this sum. If not, then once again I will explain in simple language. Focus here. Remember, he started his journey from here to here, so he has to cover a certain distance. So that distance we don't know how much distance he had to cover in within an hour. 40 kilometer, 60 kilometer, 90 kilometer, 100 kilometer. One thing we know, that he started his journey from this point. He drives a car at a speed of 60 kilometer. So we'll assume that he has covered a distance from here to here at a speed of 60 kilometer per hour. And the second part, where he has increased his speed at 90 km per hour, and he had covered a certain distance from here to here. So this distance will take as x and this distance will take as y. So from here we got the first equation, that is x upon 60, using the formula that is time equal to distance upon speed. So this is what? Distance, and this is what? Speed. So time is what? He has to cover within an 1 hour. So within and 1 hour he has to cover the maximum distance. So maximum is what, less than equal to, and within an hour means what, you will not take more than 1 hour, so it will be less than equal to 1 hour only, yes or no? So time, so this is what, time equal to distance upon speed. So time equal to distance upon speed plus time equal to distance upon speed, that means y upon 90. So in this way we got the first linear, okay, in equation. Then after that, he spent rupees 5 on 60 kilometer per hour and rupees 8. So 5 on 60 kilometer, for 60 we took x, 8 on 90 kilometers, so we took y. For 90 kilometer per hour, the distance travel is y kilometer, and he has to spend 600 rupees. He has to spend 600 rupees, only 600 rupees, not more than that. That means he has to spend only 600 or less than 600, not more than that. So from here we got the second linear inequation. So we got the two linear inequation, yes or no? What about the z? Z is what, he has to cover a certain distance. So distance from here to here is what, x, plus what, so why I wrote here plus, because we have to find the total distance from here to here, yes or no? So the total distance will be what, x plus y. For x is what, it traveled is a certain distance at a speed of 60 kilometers. So at a speed of 60 kilometers it traveled a certain distance, for that we took x. And it traveled a certain distance at a speed of 90 kilometers per hour, it we took y. So the total distance from here to here, it will be what, x plus y. So that only I am saying, just remember this int, this three part, distance, the value of z, from where you will get, from the sentence distance. What about the linear inequation, from where you will get the idea about that this sentence is what, a linear inequation? From there you will get the linear inequation to variable with the help of cost and price, as the unit for the cost and price is rupees. From the rupees section you will get the idea about the linear equation in one, linear equation to variable. As in the previous three sum, we got the idea about z from where, from rupees section. Here the rupees section will be what, for this speed, distance and time, that rupees section will be what, it will be in the form of linear inequation only, okay. And using the formula of time, distance and speed, you will get one more linear inequation. So in this way you will present your sum in the board exam. So I had explained the sum with the help of diagram to make the concept more clean and clear. I hope you all understood the sum, okay. And that's was the last sum, and the same sum actually is there in the exercise, that is a question number 8, okay. As now we had covered all the concept, all the sums, and each and every concept as we had covered from the first and the second exercise. So once again I will say, as this chapter we are divided into two type number one, it was both based on the graphical method, and type number two, it was based on how to formulate LPP. As your first exercise is based on the formulate LPP, and the second exercise, it is based on the graphical method. As now we had covered each and every sum based on the graphical method, as well as each and every sum based on the formulate also. I hope you all understood all the sums from the first exercise as well as all the sums from the second exercise. So if you want to try the miscellaneous sums, as miscellaneous sums, it is similar, it is same as the exercise only. And please refer the short example also and the MCQ questions from this chapter also, okay. So that's the end of the chapter, student. I hope you all understood the whole soul chapter. So I had explained the whole and soul chapter in a simple language. So till then, goodbye. See you in next video. Bye. Take care.